Hello friends, this video on periodic classification of elements part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. There are some merits of modern periodic table. The first thing is it is based on atomic number. The second thing is it explains the reason for periodicity of the elements. It explains the reasons. The third thing is there is no anomaly in the arrangement as we have seen in the earlier periodic tables, and the newly discovered elements could easily be accommodated in this. Also, it helps understand why elements in a group have similar property. For example, you see that all these elements in the groups we had similar properties, right? So this guy helps understand why this is happening, right? Why they have same properties, why they are all metals or why they are all non-metals, such kind of stuff. There are some advantages of modern periodic table too. First is it made the life of chemists and the chemistry students like you easy, because just by looking at the location or position of the element in the periodic table, you can guess a lot of things about the element. It is easy to remember properties of the elements based on its position in the periodic table. There is a relation between the chemical bonding in the periodic table also. So observe that the left side element combines with the right side element and they form ionic bond. For example, NaCl. This is on the left, this is on the right. Why? Because this guy is generally metal and this guy is generally non-metal. This guy wants to give electron and this guy wants to take electron. So there is a transfer of electron happens between these and they form ionic bond. But the element on the right side combines with the element of right side to form covalent bond. For example, CO2. Why? Because both on the right, both want electron. Both are electron hungry. Both are electron. Nobody is ready to give electron, right? So in this case, when nobody is ready to give electron, they share electron and they form covalent bond. And generally, the element on the left, they don't combine with the element on the left. Left and left don't combine. So this is the kind of observation we got from periodic table. Left combines with right to form ionic bond, right with right to form covalent, and left doesn't combine with left. Now it's the question time. How could the modern periodic table remove various anomalies of Mendeleev periodic table? See, first thing was Mendeleev periodic table was unable to give hydrogen a place. This was cleared by our modern periodic table. Then isotopes was confusing in Mendeleev. There was no space for isotopes. This doubt was cleared again by modern periodic table, right? And atomic number was given preference over atomic mass, and with this the cobalt nickel thing where the elements were arranged not based on the increasing atomic mass but they are based on increasing atomic number, those issues were resolved, right, by atomic number. Using atomic number as the base, these issues were resolved. Name two elements which you expect to show similar property as magnesium. And I have this magnesium. Where is my magnesium? This guy is magnesium. So I know that elements in the group will have similar property. So I can pick any of this element. I can pick this calcium. This guy is strontium. These two elements will have same chemical property because all these are part of same groups and they have a valency of 2. Right? They have valency of 2. Yeah. So they will have same chemical property because I know that if you take any group, they'll have similar chemical property. Name 3 elements which has single electron in the outermost shell. Right? Single electron is this guy. All these guys will have single electron. So I can take any of this element, lithium, sodium, potassium. So I can write here lithium, sodium, potassium. All these elements will have single element in the outermost shell. 2 elements that have 2 electrons in the outermost shell. These guys have 2 electrons. So I asked for 2. I can say magnesium, calcium. 3 elements filled with outermost electron. So I know that these elements, the last one, are filled with my outermost electrons. So I can name these guys helium, neon, argon, krypton. They are all my elements whose outermost shells are filled. Very easy. If you have periodic table in front of you, you can answer to all these questions in the fraction of seconds. Lithium, sodium, potassium are all metals. They react for to liberate hydrogen. Is any similarity in these elements? Let's see. Lithium, sodium, potassium. Yes, they have similarity, right? They are group 1 elements and they have a valence electron of 1. They have one valence electron. So that is the similarity, right? Helium is an unreactive gas and neon is a extremely low reactive gas. So let's see helium and neon. What if anything to do with their atom having common? Yes, they do have common, right? What is the common? Common is that they have filled outermost shell. Please note, you can't say they have 8 or 2 because this guy has 2 elements in outermost shell, this guy has 8, but they all filled because for this guy, this is K shell and K set needs only 2 electrons to get filled. So you can say that they have filled outermost shell. In modern periodic table, which are the metals among top 10 first elements? So top 10 first element, let's see the metal. Hydrogen is not metal, helium is not metal, lithium, beryllium is metal, and that's all. Because I'm talking about top 10, they are the only 2 metals, and then we are all non-metals, right? So I'll say lithium and beryllium are the only 2 metals in the first 10 elements in that character. See, if you have periodic table in front of you, you can answer all these questions very easily. But if you don't have periodic table in front of you, it's very difficult to answer this question. So a lot of students memorize this periodic table, and that's advisable for chemistry students to memorize at least till 30 or 40 elements. By considering their position in the periodic table, which of the following elements would you expect have maximum metallic character? So I have Ga, Ge, I have Ga, I have Ge, As, Se, Be. What is Be? It's Br actually. Br. So if you see, we know that the non-metallic character increases as we go from here to here, right? We explained that. So this guy will be the maximum non-metallic. Why? Because the non-metallic character increases as we go from left to right in the periodic table. And we've explained that. Which of the following is not a correct statement about the trend from left to right? The elements become less metallic in nature. That's correct because the metallic character is decreasing. The number of valence electrons increases. That's also correct. This guy is 1, this guy is 2, 3, 4 electrons. Correct. The atom lose their electrons more easily. This guy is incorrect because this guy is more reactive, right? And this guy is less reactive because it has to lose only 1 electron. This guy has to lose 2 electrons. So this is incorrect. The oxides become more acidic. Yeah, that's also correct. So this guy is incorrect. This is my answer. Element X forms chloride with the formula XCl2, which is a solid and high melting point. X would most likely be the same group as. See, since X forms XCl2, if you see Na forms NaCl, Mg forms MgCl2, Al form AlCl3, right? And Si form SiCl4. With this, I can say that MgCl2 is almost similar to XCl2. So I can say that this X is part of Mg. Sounds good? I've got XCl2 and MgCl2, both the chlorides formula is matching. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.